Alright, welcome back everyone. Today we're going to be looking at the next section as we move along, which is transformations of quadratic functions. Okay, so quadratics, remember, are the ones that have the f of x equals x squared. Now what a transformation is a change in the size or position of a figure. So making things bigger, flipping things around, moving things up, down, left, right, those are all considered transformations. A translation is when you just move a figure up, down, left, or right. So when you hear those words, kind of understand what they're talking about. Transformation is any direction, or making it bigger, or reflecting it, or making it smaller. Translation is just up, down, left, and right. Now there's two types that we're going to look at in this first section. I'm going to split this into two videos. The first one is the vertical and horizontal movement. So that's what you're going to look at today in this first video. In this first part, it's just the vertical movement. So we've got this constant k, and k allows things to move vertically. Okay, so if we're given a function f of x equals x squared, which we have as our parent function there, if I'm going to add or subtract, so you see the plus and minus there, add or subtract k, the graph is going to be moved up or down, and this is outside the square. Right? Now the way to tell is based on this over here on the left hand side of the screen. If the k is bigger than 0, the graph is going to be moved up. If the k is less than 0, the graph is going to be moved down. So you just think of this as your y value, moving things up and down the y-axis. So that's how that k works. And again, if you notice, it's on the outside of your x squared, and that's important to understand. Now the second variable that we're going to introduce is the variable h. So when h is added within a function, and that's the key part there, it's going to happen inside the function, the graph moves horizontally, meaning this thing is going to be going left and right. So notice the difference down here in this function. F of x equals x minus h squared. The h is within the function. Okay, so it's got these parentheses around it. It's inside that function. That is how you're going to determine if it's the h or the k. All right, if you look up above a little bit here, k is on the outside. Here, h is on the inside. That's where you're going to tell the difference. Okay, so looking at these, again, if h is greater than 0, you're going to be moving to the right, and if h is less than 0, you're going to be moving to the left. Now the tricky part of this, with this movement left and right, is the fact that your original function has a minus sign. So if I give you something like x minus 2 squared, because it has that same minus sign, the h value is actually a positive 2. So it would be moving to the right. If I gave you something like x plus 2 squared, the original negative here turns into the positive there, and the only way that a negative will turn into a positive is if you have another negative multiplied with it. And so that's actually moving to the left. Alright, so one way that I always talk about it in my classes is whatever sign you see, so if it's a negative sign like this one, you're going to be moving the opposite. Negative is normally left. In this case, we've got to think to the right. Okay, the second one is if it's a positive, we've got to be moving to the left. Okay, so it's one of those things where you just have to really pay attention and hopefully identify that early and understand that those two signs may change things. Okay, so let's look at a few of these and see what you think. So for this first one, we're just going to describe the transformations from f of x equals x squared. So you look at your example. First example is f of x equals x squared minus 7. So that minus 7 is on the outside. It's less than 0. So what is happening with this function is our graph would be moving down 7. And that's all you've got to do when it asks you to describe. Okay, the second one, you've got f of x equals 13 plus x squared. Now this can be rewritten as x squared plus 13, as long as I keep my correct signs in the correct places. So now you've got this plus 13. Well, that's greater than 0, so we know it's moving up. So this thing is moving up 13. So that's one idea of how you're going to use these vertical movements, is just make sure you're noticing that those are outside those functions, and just based on the signs moving up or down. Now for the next one, we've got f of x equals x minus 5 squared. Now that 5 is within the function. Okay, so since it's inside the function, that's going to be your h value. And remember, it's normally x minus h. So in this case, h is going to be a positive 5. Well, when h is positive, that's your right side movement. So we would say that our graph would be moving right 5. Now on this next one over here, you've got the plus 7. That's on the inside again. The only way to make that plus occur is if your h value were a negative. So we're going to say that h equals negative 7, which means I'm moving my graph left 7. Alright, so those are some of those ideas to look for. Just pay attention, make sure you're watching those signs. Now the last thing is we can put these together. So you can have two movements, which essentially moves your graph in a diagonal alignment. So with this first one, you see the plus 3 there. We know the plus is actually negative. So a plus means that we're actually moving left 3. Okay, and then we've got the negative 2 on the outside. On the outside, whether that's up or down, that's your k value. And since it's negative, you're moving down 2. And finally, on the f, we analyze these again. You've got this x minus 1. The minus means that we're moving right. So we're going to be going right 1. And then the plus 3 is an upward movement. So you're going up 3. And there's your final solution. Okay, hopefully this up, down, left, right translation movement makes sense. Watch video 2 for the second half of this. If you have questions, just contact me.